Algebra 1 Linear Review. This is a graphic organizer. If you don't have one of these, you are welcome to draw it on your own paper. I'm going to go over all of this stuff that I have filled in with you, and you can fill it in at your earliest convenience. So, I'm going to go back and do separate videos for each one of these to show you how to take the standard form, which is ax plus by equals c, and all of the stuff that you're supposed to know when you see an equation written in standard form. You should be able to look at it, maybe look at it with just a little mental math, and calculate the slope, calculate the y-intercept, calculate the x-intercept. The slope-intercept form is y equals mx plus b. You should be able to look at that and know what the slope is and know what the y-intercept is. And then with the little few mental math or simple calculations, you can find the x-intercept as well. Remember, the y-intercept is found by plugging in 0 for x. You plug in 0 for x into any equation in any form and calculate the y value. The same is true for the x-intercept. You plug in 0 for y and you can calculate the y value. You can calculate the x value. I will work examples for both of these, but this is what you learned in Algebra 1. Not only did you learn how to convert from standard form to slope-intercept or slope-intercept into standard, but you also learned how to graph each one of those. We'll save this conversation for a later video. We learned that the parent function, this is what the parent function looks like. This is the, I have it written down right here, the parent equation is y equals x. We know that the slope of that is 1 because the number in front of the x value right there is 1. This is what the graph looks like. We looked at the domain and the range. I have it written right here in both inequality notation and in interval notation. Sometimes in inequality notation you may see that they write x is an element of the real set. That's a little bit more formal. And then right here for the y, for the range, they may write y is an element, and that's a little funny looking e of the real set. But that's just another way that you can write. This is just saying the domain is all real numbers. This is saying the range is all real numbers. And this is true for both the parent function that I have graphed here, but it's also true for all lines. We talked about end behavior before. I've written right here a little, maybe a little helpful stuff to help you remember that if the graph is over here, the end of the graph is in the first quadrant, then the end behavior right here is going to be described as x approaches positive infinity because we're talking about positive values. The y is approaching positive infinity. It's the same that's true for all of the points. In the points in this first quadrant right here, all of these points have positive x values and positive y values. That may help you remember. In quadrant, this is 1, 2, 3. In quadrant 3, as x approaches negative infinity, because we're on the left side, so this is negative infinity. So as we move out to the left, the y values are approaching negative infinity. So that's the end behavior of the parent function. It's not the end behavior of every function, but it is the end behavior of the parent function. But what is true about every linear function is that the ends are always different. One's going to approach positive infinity, one's going to approach negative infinity. This particular parent function right here is increasing over its entire domain. That means that as I move along this function from left to right, the y values are increasing. That's what that means. And for all lines, it's going to depend on the slope. If you have a positive slope, the graph is going to be increasing. If you have a negative slope, the graph is going to be decreasing. All linear functions are continuous. Remember, continuous does not mean goes on forever. Continuous means that there are no gaps or breaks in the graph. And an a linear function is going to have a maximum number of roots of 1. That means at most it can only cross the x-axis at one time. Here is something that you may have been taught, slope face. This helps you remember that lines with a positive slope are going up to the right. Lines that have a negative slope are going up to the left. This is a vertical line with a little nose right there that helps you remember that vertical lines have a slope that's undefined. This is an example of a horizontal line, and it has a slope that's 0. Horizontal and vertical lines also have special equations. All other equations have both an x and a y in them. Doesn't matter if it's standard form, slope-intercept form, or point slope form. All of these equations have both an x and a y in them. Horizontal and vertical lines do not. Horizontal lines are lines that are going to be across the y-axis, so their equation is only going to be y equals some number, whatever number it crosses the y-axis at. Vertical lines are going to be drawn up and down, and their equation, their slope is undefined, but their equation is always going to be x equals some number, and if whatever number is, it's where they cross the x-axis. Another review from Algebra 1 is about parallel and perpendicular lines. This is the symbol for parallel lines. It kind of looks like a sideways 11. Perpendicular lines looks like an upside down T. Parallel lines have the same slope, and that's what I'm telling you right here, that the slope of one line is going to be equal to the slope of a second line. Perpendicular lines have opposite reciprocal slopes. So if the slope of one line is a positive number, then the slope of the line perpendicular to that one is going to be a negative number, and you're going to flip it upside down. So I'll give you some example of these when I start working my examples, but in the meantime you need to get this all copied down. The next and last thing that we're going to cover is tables, and tables for linear equations are going to have a constant change in both the x and the y values. And the slope, and I'll explain what that means when I look at an example in just a second. Slope is defined to be the change in y over the change in x. I don't think I've written it down anywhere, but we can do it over here. Let's write down slope is equal to rise over run. That's probably the definition that you remember most, and that's what the change in y is going to be your rise. How much are you going up to get from one point to the next, and then the run is how far over do you go to get to one point to the next. So here is the points that you need to remember for the parent function. These are going to be points that you see for a lot of parent functions, but for the linear parent function, it's going to pass through 0, 0, positive 1, and negative 1, and you just know it's going to make a straight line. When I say that linear tables have a constant change in the x's and the y's, that means when I look to see how is negative 2 changing to a negative 1, I'm making that change by adding 1. If I'm going from negative 1 to a 0, I'm adding 1. That's what I consider a constant change. It's a constant change of plus 1. It then looks like it may change right here. That's because to get from a 0 to a 2, it's a plus 2. To get from 2 to a 6 is a plus 4. And to get from 6 to a 8 is a plus 2. So it may look like it's not a constant change, but you'll see here in just a second that it actually is. Right here where I had a plus 1, I also had a plus 1 on this side. So I had a constant change of the change in y values was plus 1. The change in x values was also a plus 1. And so that means that for this table right here, my slope was 1. I will see that in other places. I just didn't go I didn't make a constant change in every one of these x values. I kind of skipped around a bit. So, but you can still see that this has a slope of 1. Because I found the change in y's, I'm going to find the change in x's from -2 to 0, that's a change of +2, that's a change of +4, and that's a change of +2 to get from 4 to 6. And then if I take each one of these, even when it changes from 2 on here, 0 to 2 changed, well, -2 to 0 changed, it was also. So if I write down a change of 2 on this side over a change of 2 of that side, that reduces down to 1. It's still the exact same number as it was when I was going from one point to the next point to the next point. Same thing is going to be true when I go here to the 4. There was a change of 4 right here. There was a change of 4 right there. 4 over 4 reduces down to 1. 2 over 2 reduces down to 2. So I can see the constant change even if I skip around on my table. So that's how you use a table to find your slope. Don't forget, you can also use your table to find both your x-intercept and your y-intercept. Remember, right here we said that the y-intercept was always a 0 and then a y value. So you see right here, I see a 0 and a y value, so that means that point right there, 0, 2, that is my y-intercept. And then very much like the other one, when I see for my x-intercept, if I see an x and a 0, an x value and a 0, that is my x-intercept. So -2, 0 is my x-intercept. All right, that's all of the reviewing I'm going to do for this video. I'm going to make another video where we actually work some problems.